Week 8 lesson, finding the probability of the union of two events, A or B or both. Before we continue discussing it further, let's first have a brief review on our previous topic, illustrating the probability of the union of two events. So suppose that during the new normal setup of the Department of Education, 10 matatag class of 1 De La Cruz High School consists of 30 students. 8 students prefer to study online, 15 students will use modular approach, and 5 decided to combine both modalities. What is the probability that a student will study online or modular or both? In our problem, the total sample space is 30. The first event, which is students prefer to study online, is 8. The second event, which is students will use modular approach, 15. And 5 decided to combine both modalities. So that is our intersection. Now for us, to get the probability of this, so the probability of the students that will study online or modular or both is equal to the probability of the students prefer to study online plus the probability of students will use modular approach minus the probability of the intersection of the two. So that is 8 plus 15 minus 5. 8 plus 15, that is 23, minus 5, that is 18. So the probability that a student will study online or modular or both is equal to 18 over 30. Simplifying that, that is 3 over 5. Second example, Kathy rolled the fair die and wished to find the probability of the number that turns up is odd or divisible by 5. Now, analyzing the problem, when you roll a fair die, you have 6 as your total number of sample space. So that is 1, 2, 3, 4, 5, 6. And the number that turns up is odd, you have 3. 1, 3, and 5. And for divisible by 5, you only have 1, which is 5. Now, the common between the two is 5 as well. So, they have a common intersection which is equal to 1. So, therefore, the probability that it will turns up odd or divisible by 5 is equal to 3 over 6 plus 1 over 6 minus 1 over 6 is equal to 1 half. Now, let's continue discussing how to find the probability of the union of two events A or B or both. Illustrative example number 1. Consider the experiment drawing a card from a standard deck. Let A be the event that the card is a diamond. Let B be the event that the card is a 4. And let C be the event that the card is a jack. For letter A, we have to find the probability of getting a card that is a diamond or a 4 or both. Letter B, we have to find the probability of getting a card which is a 4 or a jack or both. So before answering this, let's first have the first step, which is illustrating the total sample space. Now, in illustrating the sample space, let's first have an idea about a standard deck of cards. So a standard deck of cards has 4 suits. We have clubs, starting from ace to king, we have 13 clubs. Hearts, we also have 13 cards, which are hearts. Spades, 13 cards as well. Diamonds, 13 cards as well. Now, if we will add this 4, say 13 plus 13 plus 13 plus 13, that is equal to 52. Therefore, a standard deck of card has 52 cards on it, in which it has 4 different suits: clubs, hearts, spades, and diamonds. Step 2, find the individual probability of each event. And we already know that the sample space is 52. Now, for the first event, let A be the event that the card is a diamond. Now, going back to our last slide, the total number of diamond in a deck of card is 13. Now, the probability that we will draw a diamond card is 13 over 52. So, this is the probability of event A. Now, for event B, let B be the event that the card is a 4. Now, in our previous slide again, there are 4 fours, a club, a heart, a spade, and a diamond. So that is 4. Therefore, the total number of fours in a deck of cards is 4. And the probability of that is 4 over 52. So this is the probability of our second event. Now next, for the third event, let's see be the event that the card is Jack. Same case with event B. In a total deck of cards, there are 4 jacks, a heart, a spade, a club, and a diamond. And the probability of getting a jack in a deck of cards is also 4 over 52. So this is now the probability of our third event. Now, next step, let us now find the probability of the union of getting a diamond or getting a 4 or both. Again, there are 13 diamond cards in a deck of cards, and the probability of that is 13 over 52. And in a deck of cards, there are 4 fours. So the probability of that is 4 over 52. Now next, this is our working equation. So the probability of getting a diamond or getting a 4 or both is equal to the probability of getting a diamond plus the probability of getting a 4 minus the probability of the intersection of getting a diamond and a 4. Okay? Now, since we already have the probability of the first event and the second event, we still need to get the probability of their intersection. Now, their intersection, based on the figure, they have both 4 diamonds. Therefore, they have 1 intersection, and that the probability of that is 1 over 52. Now, going back to the working equation, all you need to do now is to substitute the probability of A, which is 13 over 52, plus the probability of B, which is 4 over 52, minus the intersection of the 2, which is 1 over 52. So, we will now have 13 over 52 plus 4 over 52 minus 1 over 52. 13 plus 4, that is 17, minus 1, that is 16. So, we will have now 16 over 52. Now, simplifying 16 over 52, we will now have 4 over 13. So, therefore, the probability that we will get a diamond or a 4 or both is 4 over 13. So, that's how we will answer letter A. Next step, let's answer the second question, letter B. Find the probability of getting a 4 or getting a jack or getting both. Now, for this, we already know that the probability of getting a 4 is 4 over 52. And we also now know that the probability of getting a jack is also 4 over 52. Now, next, our working equation will become like this. The probability of the union of getting a 4 or a jack or both is equal to the probability of getting a 4 plus the probability of getting a jack. We do not have any intersection because a 4 and a jack doesn't have any common element. So therefore, this is now our working equation. And with that, substituting the probability of getting a 4 and the probability of getting a jack, that is equal to 4 over 52 plus 4 over 52. 4 plus 4, that is 8. We will now have 8 over 52. Now, 8 over 52, simplifying it, we will get 2 over 13. Therefore, the probability of getting a 4 or getting a jack or both is 2 over 13. So, that's how we answer letter B of number 1. Illustrative example number 2. Suppose that today there is 90% chance of sun, 20% chance of rain, and a 15% chance of both sun and rain. What is the probability of sun or rain? Now, reading again the problem and analyzing it, let's first identify the different events that we have. So, the first event that we have is 90% chance of sun, in which we will be representing it as A. 20% chance of rain, represent it as your second event B. And a 15% chance of both sun and rain. Take note of the word both and N. They are signifies that this 15% right here is the intersection of the two. Okay? Now next, another key word in our problem is the word chance. Chance is the another term for probability, which means that 90%, 20%, and 15% are already probability of each event. Okay? And with that, we will now write down the given. The probability of sunny day today is 90%. The probability that it will rain today, that is 20%. And the probability that it will rain or it will be sunny day or both is 15%. Since they are already in probability, all we need to do now is just continue substituting them in our working equation, which is equal to the probability of A and B, or should I say the probability of A or B is equal to the probability of A plus the probability of B minus the probability of their intersection. So we will now have 90 plus 20 minus 15. 90 plus 20, that is 110, minus 15, that is 95. Therefore, the probability that it will sun or rain today is equal to 95%. So that's it. That's how you answer number 2. Third illustrative example. So consider the experiment of flipping 3 coins and recording the sequence of heads and tails. Let B be the event that there is at least one heads. Let C be the event that the third coin is a tail. And let D be the event that the first coin is a head. We have to find the probability of the union of getting the third coin as a tail or getting the first coin as a head or both. In answering the third illustrative example, first things first, we have to illustrate the sample space. Now, since we are flipping 3 coins, in illustrating the sample space, we will use 3 diagrams. So, our experiment is flipping 3 coins. Let's say, let's flip first the first coin. In flipping the first coin, we have 2 outcomes, getting a head or getting a tail. Now, let's flip another coin. In flipping the second coin, we also have 2 outcomes, getting a head and getting a tail, but in consideration with the first flip coin. Now, say the first flip coin is head. Now, there is a chance that the second coin will be flipped as head as well. Now, since, say, we still have the first coin as head, there is a chance that the second flip coin is already a tail. Okay? Now, next, say the first coin is tail, there is a chance that the second flip coin is head. Now, if the first coin again is tail, there is a chance that the second flip will be tail again. Now, we're done with our second coin. Now, for the third coin, say the first flip coin is heads and the second flip coin is head, there is a chance that the outcome for the third coin will also be a head or a tail. So, let's first start with the head. So, head on the first coin, head on the second coin. The third coin may be a head again. Next, first coin is head, second coin is head. The third coin may be a tail. Next, first coin is a head, second coin is a tail. There is a chance that the third coin will be a head. Next, first coin is head, second coin is tail. The third coin may be a tail. Now, continuing the process, first coin, tail, second head, and then head again. So, tail, head, tail, 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 head, and then we have tail, tail, and tail. Okay? Now, let's combine the outcomes. The first coin is heads, the second coin is heads, the third coin is heads. So, we have 3 heads as our first outcome. Second outcome, first coin is head, second coin is head, the third coin is tail. So, we have 2 heads and a tail. Second outcome. Third outcome, a head, a tail, and a head. So, that is our third outcome. Fourth outcome, a head, a tail, and a tail. Okay? Next outcome, fifth outcome, if the first coin flipped is tail, the second flip coin is heads, and the third flip coin is heads, we have tail, head, and head, which will be our fifth outcome. For the sixth outcome, we have tail, head, and tail. Seventh outcome, tail, tail, head. And then for the last outcome, we have tail, tail, and tail. So a total of 8 outcomes. Therefore, in flipping 3 coins, we have 8 outcomes. So the sample space is 8. Now next, going back with the problem, according to the problem, let's see be the event that the third coin is a tail. Again, let's see be the event that the third coin is a tail. Now look at the third coin. You have to find here the outcomes in which the third coin is a tail. And then you have to count it. Okay? So the second outcome is head, head, tails, in which the last or the third flipped coin is a tail, which is connected to the first event. Let's see. And then we have the fourth event, head, tail, tails, in which the third flipped coin produce a tail again. Next is tail, head, tails. And then we have tail, tail, and tails. Now, the total outcome of flipping the third coin in which it will become tail is 4. Now, next, let D be the event that the first coin is a head. Now, we have the second event in which we have to look for the first coin in which the outcome is a head. Now, looking in our illustration in the tree diagram on the left, these are the outcomes in which the first coin is a head. H, 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 heads, heads, heads. And then we have head, head, tail, head, tail, head, head, tail, and tail. So, the total number of outcomes in which the first coin is a head is also 4. Now, next, we have to find the probability of the union of the third coin being a tail or the first coin being a head or both. Okay? Now, since we are looking for the union of the two, let's first identify their intersection. So, what is the intersection of getting the third coin as a tail and getting the first coin as a head? Now, allow me to show you the illustration again. So, in observing the illustration, we have 1, 2. They have in common HHT and HTT. So, therefore, their intersection is 2. And the probability of that intersection is 2 over 8. We're done analyzing the problem. Let's now proceed with the second step, in which finding the probability of the union of flipping a coin in which the third coin is a tail, or flipping the first coin in which it will be a head, or both. So, let's first get their individual probabilities. The probability of flipping a coin in which the third coin is a tail is 4 over 8. And the probability of flipping the first coin in which it will become a head is 4 over 8 as well. And their intersection is 2 over 8. Now, proceeding with the working equation, we will now have 4 plus 4 minus 2. 4 plus 4, that is 8, minus 2, that is 6. And the probability of the union of the two is 6 over 8. Now, simplifying this, we will now have 3 over 4. Therefore, the probability that the first coin is a head, third coin is a tail, or both is 3 over 4. So, that's how we will answer illustrative example number 3. With that, your turn. You will be answering items 1 to 15 of instructional support pages 21 to 22. Do not forget to show your complete solutions. Again, you have to solve items 1 to 15 of instructional support pages 21 and 22. Do not forget to write down your complete solutions. And do not forget to write this down on your paper, your name, your grade and section, the date that you answered your module, and the week number, which is week number 8. So that's it for week 8.